It's a private biotech company that I wasn't really getting this in the presentation as a product. Şu company var öbürümüz kurumlar big company that we provide all the reagents for scientists to do embryonic stem cells. We provide the cells, we provide the media, we provide antibodies and everything that scientists need to do embryonic stem cells. For example, to work with embryonic stem cells for the students, you have to have another cell called feeder cell, and then you have to have a special media for the embryonic stem cells. And then all the media and serum that they use has to be qualified for ES stem cells. So that's our company. We do that. We provide this for all the scientists and companies around the world. We also do all other services like DNA fingerprinting, karyotyping, pathogen screening, and everything that they do. So that's done with the company. Okay? Human embryonic stem cell. Human embryonic stem cell, what is it? I'm sure you have heard about embryonic stem cell a lot because President Bush made a policy that scientists cannot be funded by federal money. And he thinks that to extract embryonic stem cells, you have to kill the embryo, which is not true. That's why President Bush thought that we should limit the funding. And what is embryonic stem cell? Embryonic stem cells are the cells that it will differentiate to any cell types that you want. It can turn into heart cells, it can turn into lung cells, it can turn into brain cells. So the good thing about embryonic stem cell, once you have it in the laboratory, you can manipulate that to turn any cell that you want, and you can study drug screening and diseases. So it's called pluripotent. It has the potential to be any cells in the body. So because of that, because of this potential, it's a good source to do regenerative medicine, drug screening, and early human development. Now, where does human embryonic stem cells come from? How they prepare this? In vitro fertilization clinics, IVGF, so in vitro fertilization clinics, those people, those women who cannot have babies, so they will go to these clinics, they will have sperm from the husband and egg from the wife. They will do in vitro and they will create 2 cell zygotes, okay, 2 cells, very early in the test tube. They will prepare, let's say, hundreds of them. And then they will put 1 or 2 in the body. And then once they have the baby, the remaining of those cells will be kept in the liquid nitrogen for about a year or 2 years. And it costs a lot of money. So when people have a number of children that they have, they say they don't need them anymore. Well, so after that, so they don't need those embryos. And they have to pay lots of money to keep them. And so what they do is they throw them. They just throw them to the garbage. They destroy them. So scientists, they will go and use those embryos that they don't want anybody, but they don't want anybody. They will get those embryonic stem cells from those cells. So it is not something that we get from pregnant women. No, no. It is the embryo that's in the clinic and they don't want it. It's outside the body. So because of this, some people say that still you have to destroy those embryos. Even though it's unwanted, they still have to, so it's not good. But scientists say, well, you are going to throw that away anyway. You are going to destroy that anyway. Instead of destroying them, we will get a cell, single cell, and it will be used for screening, for so many good things. So that is the debate. Because of that, in August 2001, President Bush, he still believed that he said no embryonic stem cell. Now, so human embryonic stem cell only they isolated in 1998. It's almost 10 years old. It's a new science. It's a new thing. But in 10 years, the progress was really, really high. It was great progress in this area. So as I said, it's outside the body. It's only in vitro. And then once they isolate the cells, then we come. Our company, we don't go get the cells from embryos, but once they isolate the cell, then we know how to propagate them. We know how to keep them. We know how to propagate them. So that's what our company. So it's unwanted in vitro fertilization embryos, and that's where they get ES cells, embryonic stem cells. And the good thing about that is that they will provide limitless number of cells. Like the old way of doing this is that if they want to study lung cells for drug screening for anything, they would get a few cells from human lungs, that's cadavers, the dead people, and they will do. But human ES cells, we can provide limitless, no end for them from the same cell. So, as I said, ES cells, they can. What are the characterization of ES cells? ES cells can replicate, make themselves endlessly, forever. And they are normal cells. They are not cancer cells. They are normal cells. And they will give you all the cells in the body. But ES cells, embryonic stem cells, are not embryo. It means that if you put embryonic stem cell in the woman's uterus, it will not give you a baby. Okay, so ES cells are not embryo. People don't know that. ES cells are just the cells that you can create cells in the laboratory. It is not embryo. So I just want to show you a slide how many cell types we can make. So embryonic stem cells called pluripotent. It will make cells all the time unless you change the way they grow. You add hormones, you add different growth factors, you add all that, but you can tell them what to do. And once you do that, it can go to, we can create this, all the cells, like a skin cell, the epidermis they call it, all the connective tissue, or you can even do all the muscles, heart, and also it will give you lung cells, and almost any cells, even the brain cells, okay, so it's just endless things. That's the good thing about embryonic stem cells. You can create all the cells that you want in the laboratory. And that will give you all the brain cells, and this side will give you heart cells, and that side will give you lung cells. So with this characterization, this is a great thing for replacement therapy. There are people, for example, that they cannot make insulin, diabetes. Those cells cannot make insulin, so you have to take insulin. You can create the cells that will make insulin, and they will replace that in the body, and it will make, this is scientifically, technically true. Okay? As I said, it has been only 10 years, technically true. And or people who have a blood problem, you can change. You can give it few cells from the skin. You can make embryonic stem cell which produce certain cell types. So you can genetically defect disease can be solved. This is just an example that people have been working using animal models. So for example, all the heart injury, even visual injury, spinal cord injury, and it works in the animal system. But in the United States, because of federal restriction, you cannot do